所以我就黄教授就请他的博士班学生在下个月就要进行口试了，就是准博士林博士准博士林先生Andrew 林他是这个印尼的这个学生他取得博士学位来讲一个主题是 Fault Management Against Optical Distribution Network Failures in Ethernet Passive Optical Network。那个光纤拉到家里面已经非常普及了。那我刚刚跟他们聊了一下，在台湾的普及率是30%，然后在这个日本跟韩国呢，其实光纤的这个最后一里路拉到家里面从电信来终端去那已经超过50%到60%了，所以这个是非常普及的一个技术那因为这个林博士是从印尼过来，他会用英文演讲那我现在开始用英文来帮他介绍一下。So originally I invited Professor Huang, the chairperson from the Department of Computer Science and Engineering, Yuanzi University, to deliver a speech today. Unfortunately, Professor Huang just underwent surgery 7 days ago, and right now I think it's not suitable to invite him directly to here. So Professor Huang invited his PhD student, Andrew Lin, to deliver the speech today. I think Andrew Lin, Mr. Lin is going to have his final oral examination next month. So right now, he's very soon he will be a doctor, a PhD. So I think today, I think Mr. Lin is from Indonesia. So today he will he will deliver a speech in English. Actually, I got 2 master students from Indonesia. So today, one here, they come here, and so later maybe you can have a chat later. Okay, so today's topic is fault management against the optical distribution network in Ethernet passive optical network. As I have just said in Chinese, the EPON network have very large coverage in Taiwan, maybe 30% in Taiwan, maybe 60% or 50% in Korea and Japan. So it's very hot topic right now. So that Mr. Lin and Drew will talk about this topic. Okay, so let's make a big hand to Mr. Lin. Welcome him. Okay.
Thank you so much, Professor Jacob, for the introduction. Good afternoon, everyone. It's been an honor for me to be here. Actually, like Professor Jiang mentioned, my professor is supposed to be here to deliver the speech, but because of some matters, so cannot make it today. So today I'm going to share with you part of our research in our lab in Yuanzi University. The topic is fault management against the optical distribution network in the EPON. Basically, in our lab, we have different research area in terms of the EPON, but today I try to discuss with you about the fault management. So let's begin. So here is our agenda for today. First, I'm going to introduce with you about why we need the optical network in the access network. What's the reason behind why is the optical network is so important? And therefore, many network operators now, they try to develop the optical network in their last month. And after that, I'm going to introduce about the EPON, general architecture and operation. EPON is one of the technology used in the PON deployment. Later we are going to see what's exactly the advantage of the EPON, why they use it. And after that, then we are going deeper for the resilience and service protections in the EPON. And we are going to see also what's the previous research work have been done concerning about the resilience and the service protections in the EPON. And after that, here probably we already did this research, but I hope it can give you some ideas for future research. And after that, we are going to have the Q&A. So let's start first. So as we know nowadays that the multimedia services application is always evolving. We can see, for example, a few years ago, probably we just have like a standard definition video, but nowadays, even we have like a 3D televisions or maybe ultra high definition, which is we can call it can consume a lot of huge amount of bandwidth, and actually these issues become more and more important. Therefore, the network operator now is thinking, especially in the access network, because we are talking the access network, how can we develop a simple and high capacity, cost efficient, as well as the providing the customers with a high quality of service. Because this kind of bandwidth intensive application can make the bandwidth suffer. For example, for the ultra high definition, probably can consume more than 10 megabits. So it's quite a lot of bandwidth. So here is the challenges in the access network. So first is in the last mile network, because some people say that the last mile can be a bottleneck. And the second one is the architecture of the access network itself to support the bandwidth intensive application, like I already mentioned, many applications. And the last one can be built under the existing legacy system, because if we just change, the existing legacy system, it means that the network operator need to pay more, to develop the infrastructure. So it's better. How can the network operator can build the system based on their legacy system? So we are going to see the importance of the optical network, because one of the solutions actually in the access network is that we can use the optical network to provide or to give the network operator such advantages, such as a simple, high capacity, cost efficient, and more. So here is just to give us some idea about per user bandwidth requirement for the new service. It's keep increasing over the years. So as we can see here, this is for the future. You can imagine that one users can have, for example, 100 HD channels or 100 SD channels and so more. So we can imagine how big is the bandwidth. And therefore, from the network operator point of view perspective, we can see that, how can the network operator can provide such a bandwidth to the customers, because we have very limited bandwidth. And here is some like a ruler going to the future. So in the near future, we can see that the bandwidth in the residential area will keep growing. Here is the other data based on the Cisco. We can see here that in the 2016, we can see it's 7 times. 7 times it is in 2012. So we can imagine that the video traffic is very high compared with the other traffic. Therefore, we need how can the network operator can provide you know enough bandwidth for such intensive bandwidth intensive applications. So in the access network, actually, in particular, if we are talking about the optical access network, we can have different technologies. It can be hybrid, or it can be pure optical, or it can be some other technologies. But today, we just concentrate on we call it the passive optical network. Why we use the passive optical network? Later we are discuss more about this. So like you can see in the picture, so access network is just left-hand side, okay? Or for your point of view is right-hand side. So just we are talking about this area, not in this area, okay? Just that area. So, I already mentioned that, you know, in the near future that we are going to have a very how to say that evolved multimedia application which demand on the higher bandwidth. Therefore, optical fiber is known as one of the solutions actually in the access network to offer future bandwidth intensive and emerging applications. And based on the citation that we have here, that fiber-based broadband subscribers are expected to grow more than almost 200 million by 2015 worldwide. So we can see that, you know, the evolving of the copper, probably copper to the optical. And in the optical technologies, in the access network, because we can have different technologies, basically, PON in particular is regarded as one of the solutions in the optical access network. Why? Because it's simple, efficient, and cost-effective. Why is simple? Because we don't have any active components between the central office and the user's area. Later we are going to see details about the architecture of the PON. And because we don't have any active components, you know, between the central office and the user sides, it means that the maintenance cost is more cheap compared with the other technologies. So it's quite interesting topic to discuss about the passive optical network, and it can probably one of your future research work. So here's the technology penetration in the access network. This is based on the paper in November 2013. It's quite new. I think this one is not focusing on the one nations. This is the average, so in the worldwide. And we can see that the trend for the optical fiber, it keeps increasing over the years. So in 2024, you know, it's almost 50% of the of the access network will be penetrated by the fiber optic, because, you know, theoretically fiber optic can provide you almost unlimited bandwidth, theoretically, okay? And here is some data. We got this data from the FTTH Council in 2011. So actually, we can see here Taiwan is quite high. The penetrations is almost 30%, but mostly the penetration is not the FTTH, like in the Arab Emirate. Is mostly is just for the FTTB plus LAN technology. So it's a little bit hybrid between the fiber and the coax. So in the optical network, access network, I mean, like I already mentioned that, you know, PON can be categorized as the best solution among the optical technologies in the access network. And in the PON itself, it can be categorized at different types. based on the multiplexing scheme. So we can have like OFDM, we can have a WDM, we can have a C or CDM and the WDM or the PDM. And to the best of my knowledge, until now, actually, only the TDM has been standardized up to today. The other is still in the task force or in the just in the research or in the lab. So, PON. What is PON? Some people say that PON is the leading technology being used in FTTH. I mean, FTTX. It can be FTTH, FTTB, or FTTN, and so on. And PON has a different topology from other network technologies because in the downstream directions, later we are going to see that, it uses point to multi-point topology. Later we are going to discuss more about this one. And the other thing, why is PON is cost effective, I can say, is a single strand of fiber goes to a passive optical splitter. So we don't have any active components between the central office and the customer premise, like I already mentioned before. And after that, after the fiber goes to the passive splitter, it will split to the 32, 64 or more different lines. So it can support up to many customers. Later we are going to see that a single state-of-the-art OLT can support up to 30,000 customers. And in the downstream and upstream data directions, I mean, it can support the data rates to up to 10 gigabits per second in 2009, I think. In 2009, they have a new standard for the EPON, which can support multi-rates, 1 gigabits per second and 10 gigabits per second. And in July 2013, we have a new standard. They call it the SIPON, Surface Interoperability Ethernet Passive Optical Network. In this standard, actually, they discuss more about higher functionalities in the EPON system. So we can have more higher functionalities in the networking layers. So we can have a different PON standards, basically. GPON and EPON. And if you are interested about the GPON, probably you can just Googling it. It's based on the ATM. I think it's famous in the European and the US country. Mostly they use a GPON, I think. And for the Asia, I think most of it use the EPON. Because you know that at the customer termination, most of the computer or most of the customer, I can say, use what? Ethernet as their system. So here is the EPON. It's standardized actually it was in June 2004. And why is EPON is one of the best solutions? Because low maintenance cost and compatibility compared to the existing network. So it's like I already mentioned that one of the challenges is how can we build up a system under our legacy system. So it has a compatibility. Sorry. It's updated in 2009 for the multi-rates capability and update again in 2013 for the higher functionalities. You can check just Googling it for the standard about the EPON standard if you want to know more about these standards. So that's the first part of the introductions. We already discussed about why is the optical access become one of the best solutions in the access network. And among the optical access technologies, PON is what? One of the best solutions. And in the PON, we have different standards, GPON and EPON. And in this time, we are going to discuss about EPON general architecture and operation in more details. Because before I just introduced in the high level. So now we try to go deeper a little bit. So I think probably most of you also already know what is OLT, what is ONU. Just want to introduce to you some terminologies that we are going to use in this speech. So first is the OLT and the ONUs. What is the OLT and what is the ONU is here, already in the slides. So basically, OLT located in the local exchange, or we call it the central office, connecting the optical access network to the metro backbone. If you remember, we have the pictures about the access network. So here is the OLT in the central office connecting to the metro backbone. And on the contrary, optical network units. What is the optical network unit? Optical network unit basically provides the interface between the customers, so it can support the triple play services such as the voice, data, video, and more. Even now it's not triple play services. They say it's quadruple services. So here's the two major terminologies that we are going to use over the slides. So here's the different or various deployment schemes for the EPON. So as we can see here, actually in the left hand side of me, we have the fixed mobile convergence. They call it a fixed mobile convergence because we have the EPON ONU connected to the, it can be wireless, I mean WiMAX, or it can be also the LTE. So a lot of research has been done so far concerning about the fixed mobile convergence, and it's quite famous now about talking about the fixed mobile convergence between the optical and the wireless. And the second one is like the FTTH, is the fiber to the home. And the next is the fiber to the building, or it can be fiber to the LAN. Like in the Taiwan, they said it's fiber to the building plus LAN technologies. It's similar like that. And also it can be fiber to the customer equipment directly. I don't know, maybe in the Korea or South Korea. So actually in this speech, we are focusing on the fiber to the building, or we can say also fiber to the business or commercials. So if you are interested about the fixed mobile convergence or the other area of the schemes in the EPON, you can try to Googling it. So here's the background of the EPON. Like I mentioned before that, the EPON systems are progressively used by the network operators around the world to offer diverse services like the video, voice, and data as well. So one single state-of-the-art OLT can support up to 30,000 customers. So it seems like it's a very big customer. 30,000 customers just with a single state-of-the-art OLT. And EPON platform density, it can be for the FTTH, FTTB, FTTN, and so on. In this speech, like I already mentioned, that we are focusing on the business because mostly the network operator will provide resilience and service protections just for the business customers because they have a service level agreement. If something happened to the system, you need, the network operator need to pay fine. Later we are going to see about the issues concerning the EPON. One of it is about the resilience. So here's just pictures of the state-of-the-art OLT. in our lab, we don't have this kind of state-of-the-art. I assume it should be very expensive because it can support up to 30,000. It's like the rack of OLT. So here is support the multi-rates, like I mentioned in the 2009. EPON can support multi-rates 1G and 10G. 1G upstream, 10G downstream. And this is just the example, the pictures you can see. So probably we can have some idea about what is the OLT, how is the shape and everything. So here's the operations, the architecture and the operations. So we have the customers, the ONUs, and the OLT located at the central office. So in the upstream directions, we use the TDMA, the time division multiplexing. I'm going to share about this one a little bit more details. And for the upstreams, downstreams, they use the point to multi-point, like I already mentioned. So the OLT will send the data, because we just have a splitter here, the data will be split according to the number of lines. For example, I have 32 ONUs, it means that the data will be split into 32 ONUs, lines. And after that, then each ONU will filter the data based on the logical link identifier, or the LLID. And as we can see here, actually, each ONU will receive the same data, right? You can see everyone is received the blue data, for example. But only the ONU number 3, we assume that one is the ONU number 3, accept the blue rectangle or the blue data. Why? Because the blue rectangle or data have the same LLID. Because if you don't have the same LLID, then it means that the ONU should drop that packet. So here's the unique one, is the point to multi-point. And I'm going to back to the upstreams DBA. Now we are going at the opposite. So how can the user send the data to the OLT without any collisions in the passive splitter? Because here, they share the bandwidth. So it means at a given time, only one ONU can send the data to the OLT. That's why they call it the time division multiplexing. So all of this one will be controlled by the OLT. It's a centralized. So OLT will be responsible to allocate the bandwidth to each ONU. So for example here, ONU want to send the data to the OLT or to the internet. So the ONU only can send the data at the given time. So for example, this one is number 1, number 2, and number 3. So OLT will calculate the bandwidth for each ONU. We call it the dynamic bandwidth allocations. And how can the OLT know how much bandwidth that one ONU needs? In the EPON system, we have the protocols, the control protocols. We call it the MPCP, multi-point control protocols. It consists of several messages, but today we concentrate on just two. The gate message, which is from the OLT to the ONU, and the report message, which is from the ONU to the OLT. I'm going to explain more details about this because at the further slides, we are going to have this kind of terminologies in more deeper. So, for example, like I mentioned before, how can the OLT know that ONU1 need some amount of bandwidth? So at first, the ONU will send its buffer occupancy, how much bandwidth that I need, how much bandwidth that I have in my buffer. It will send with the report message. So after the ONU send the report message to the OLT, then now the OLT know how much bandwidth that particular ONU needs. And just to mention, you can further Googling for it. In the OLT, how they do the dynamic bandwidth allocations, it can be divided into two schemes, mechanism or schemes, the online or the offline. So what's the differences? So basically the main differences, we call it like, one is on the fly, one is not. What it means by the on the fly. Once the ONU send the report message to the OLT directly allocate the bandwidth to that particular ONU. That is for the on the fly, it's online. But for the OLT, it's the other way around. What means that the other way around? It means that the OLT will have to wait until all of the ONU send the report message. So after the OLT receive all of the report messages from the ONUs, then the OLT will do the dynamic bandwidth allocations. Each schemes have their own advantages and disadvantages. For us in our lab, mostly we are using the offline dynamic bandwidth allocations. But if you are interested about the online, and you can Googling for it. We call it the IPAC. It's the first original paper introduced about the online scheduling bandwidth allocations. IPAC, IPACT. The author is Glenn Kramer, one of the pioneer about the EPON. So, in the EPON, we have some major issues. If you are interested, in our lab, we are discussing about the resource allocation management, which is the dynamic bandwidth allocations. And we publish also some papers about this one. And we are working also in the energy efficiency in EPON. I think now is a trend about the green computing, the green world. And today we are going to talk about the resilience and service protections topic. And here also we have the multimedia services, like the video on demand, IPTV, peer-to-peer streaming, and so on. And one of my friends, the PhD student also, have more information about this. You can directly, if you are interested about that, you can directly ask him, because he is here with us. And the other one is about the quality of experience, the quality of service. Because basically, we are just talking about the quality of service without concerning about the quality of experience. But in the real world, we need also to consider about the quality of experience. I don't have enough time to discuss about these two in details. Just probably for a simplicity, the quality of experience is more in the user's perspective. For example, if we are talking about you are a customer, I'm a network provider, and I'm talking about how about the jitter? How about I think from the customer's perspective, what is jitter? They don't understand. For example, like that. So here is more in the user's perspective. And a few papers actually discussing about the new standard, because just published last year. But we found one or two papers already published discussing about how to use the new standard with a higher levels of functionalities. And the last one is the next generation broadband access network, which can be a fixed mobile convergence. This one is famous now, like I will mention. Optical as the backbone, and for the customers, they use the wireless, such as the LTE or WiMAX. Or else, they can use the hybrid TDM and WDM PON. Or a lot of research have been done also concerning about how can we use the OCDM and OFDM. It's quite interesting if, for the next generation broadband access network. But today, I already underlined that we just focus on the resilience and the service protections. So there's the introductions. I hope can give you some background about the optical and the EPON. Now, for the rest of the discussions, we are going to talk about the resilience and service protections. And I think in this one, I'm not going to discuss very details because I think this one can just give you some ideas. Probably in the future, you can propose a new architecture concerning about the service protections or fault management in the EPON. So here's the challenges concerning, in terms of the resilience and service protections in the EPON. So I already mentioned here that EPON platform density can be cover wide area, FTTH, FTTB, and FTTN, and so more. And the EPON can cover 3,000 customers, and you can imagine that once the fault occurs in the link, what happens? If we have many customers, then the network operator surely will experience high loss of revenues. Even worse, if the customers is the business or the commercial customers, it means that the network operator need to pay fine because usually in the SLA you have the uptime and the downtime. What's the uptime? What's the downtime? And for the QoS requirements for the mobile backhauling, they call it the 5-9S. So if we can see here, 99 plus 999, availability. For me, is the uptime should be like 100%. What's the downtime? Just 0.000 something. So based on these facts, we can see that it is very important how the network operator can protect their system against any failures in their system. So here's some facts. And before I forgot, here is also important because we need to concentrate also in which part of the system that the fault prone to occur. For example, here, according to some citations here we have, that 80% of the installed EPON failures occur within the first last mile. Later we are going to see where is the first or last mile. That is within the distribution drop segments of the network. So it is very important for us to concerning about these facts. Because what? Because 80% is occurred just in the ODN. Therefore, in today's speech, we are focusing on the ODN, optical distribution network, which is the distribution drop segments. It can be link failures or it can be transceiver failures. Depends. I think I need also to say something about the 911 call. I think I have the slides later. We can see. So here is the some protections in the standard. So this one is in the standard. So if we can open the standard, for example, the SIPON standard, they already design a standard. They call it a trunk protection and the tree protections. How can the network operator protect their system against the failures? So here we call it the trunk protection. So here is the trunk. It's like a tree. We have the trunk and we have the tree, not the tree, the branch. And as we can see here in the standard, they always use 2 OLTs to protect their system. So if we use they call it the trunk protections, it means that we duplicate the feeder fiber. And in here, for example, the feeder fiber is fault. Okay, the ODN is here. This is the ODN, and this is the feeder fiber part. So in the trunk protections, they concern about the feeder fiber. If this one, the link is fault, then it will switch automatically to the other OLTs. Basically, this one is, of course, it's a very good protections, but we have 2 OLTs, and we need to discuss further about this one. What happens if this one is the working line and this one is the protections line? What happens if there is nothing happen to the system? So this one is kind of wasted because we don't use it. So it's kind of wasted. But some people also propose how can we, use the protections mechanism. I mean, not protection line to deliver the data. But the other problem, if we have a 2 OLT working in the same EPON system, we have some synchronization issues here because we have 2 OLT. Each OLT needs to synchronize within each other. If not, we have a problem in our EPON system. And the second one have a wider area of protections. It protects the feeder fiber as well as the branch. They call it the tree protections. It seems like almost 1+1 protections. So here, if something happened to the drop distribution fiber, which is 80% of the PON system failures occurs between here. With the tree protections, we can protect this one. For example, here, if something happened to this link, then the ONU can switch and send the data to the other PON system. I mean, not PON system, the other OLT. Again, here we can see that the main problem is how can we use, the idle fiber line or the link here, because it's kind of wasted. And another thing is that if we have 2 working ONU in the same system, I mentioned before, we have a problem with what? The synchronization issues. So it's just from the standard, we can found in the SIPON standard, how can they protect the EPON system with 2 kinds of approaches, the tree protections and the trunk protections. And in today's speech, actually, we are not going to discuss more about this one, but we just propose a new approach, a new different perspective of how can we protect the EPON systems, especially in the drop distribution fiber. So each protection schemes, of course, have its own disadvantages and its own advantages. So in today's speech, later on, we are going to see about some ideas how we can protect those faults with our proposed architecture. So here's some related work that have been done so far. in the slides, I already put the citations. So here, as we can see, most of them is concentrated on the fault monitoring, but not on the post-fault protections. And before I forget, there are three important things that we need to consider if we talk about the resilience and protections in the EPON. One is detections, second one is localization, and the third one is the post-fault protections. So first, we need to detect first. If something happened to the link, then how the system can detect? Because without any detections, who knows something happened to the system before the customer would call? Why I cannot connect to the internet, for example? We cannot, how to say that? We cannot use that kind of approach. Wait until the customer call and then there's something happened to the system. Because later we are going to see that we have the SLA for the post-fault switching times, which is less than 50 milliseconds. So it means if something happened to the system, less than 50 milliseconds, the system should be up again. So it's a very big challenge. It's just 50 milliseconds. So here is the some related work. Most of it use the OTDR. OTDR is kind of a device that can localize. So mostly the OTDR can localize. It means can localize means that you can exactly point out where is the fault. Because usually fiber is underground, yes, under the soil. So in which area actually we have the fiber faults, they will use the OTDR. Exactly in which kilometer. We have around 5 kilometers between the ONU and the what they call it, the splitter, and around 10 to 15 kilometers from the passive splitter to the OLT. So totally it's around 20 kilometers. So basically this is our previous work in the Starring. It's for the multiple PON system. Our professor have published papers talking about how can we protect the EPON systems against multiple link fault in the multiple EPON systems. So here's the motivations behind the resilience and protections. So first is we concentrate on the detections because for the localization we can use that device, the OTDR. So first we need the detections. How can we design detection mechanisms so that if something happened to the system, just in few milliseconds, we can detect and then restore. Not only detect, but restore. And the second one, we need to guarantee to deliver the EF or the voice traffic. Why? Because according to the FCC, 1/3 of service disruption are due to the fiber cable problems, and many of those disruptions have involved Lifeline 911 service. 911 service, of course, is very important. If something happened, then the system cannot restore within the some interval of time, then what happened to this call? It can be dropped. So it's very important how can we detect and restore the EPON system in time. And the other one is to maintain the quality of service. It means that we need to guarantee the EF traffic, of course, but how about the other traffic? We need also to consider about that. We cannot just satisfy, for example, the EF traffic, and then we don't care about the other traffic. The video traffic, the data traffic also is very important. And the last important thing to discuss is about the restoration time, the quality of restoration. How much time that the system need to restore its own system after the link fault. And according to the to the some papers, it should be below 50 milliseconds. So it's quite fast. We need to consider also about this one. I hope I can deliver it quite well, so you can have some ideas about the resilience and service protections in the EPON. Because for the next couple of slides, we are going about discussing about our work. So it's a little bit going deeper, but I hope I can deliver it to you as simple as it is, and can give you some ideas about the resilience and service protections. So here is the proposed architecture. The first thing we need to know that this line is not necessary to be a ring. It's just similar like a ring. It can be designed in another topologies, but for the easy clarification, so we just put it like that. I have different pictures later we can see. So first, because we concentrate about this one, like I already mentioned that 80% of the fault is happened to this one, and if we digging about the faults itself, 80% is happened to this area, and among the 80%, you know, mostly the fail is in the link or in the transceiver of the ONU, so in the laser. So in this talk, we concentrate on the transceiver fail or the link fail, not the other fail. So here is the idea. First, we have we call it the restoration group, which is we are going to group the ONU into the restoration group. Each one will have its own adjacent node. So if something happened to this ONU, it can send the data to this ONU in the counterclockwise. This one is not bidirectional, it's just one directional. So here's another different pictures. If fault occurs, how can we deliver the data? We are going to discuss this more details with the example later on. So as we can see here, we have some terminologies. I hope I'm not confused you with these terminologies. We have the affected node, we have the adjacent node, and we have the unaffected node. What is the affected node? Affected node means that the link to that particular ONU is fault, or the transceiver of this particular ONU is fault. It means that it became affected node. How about the adjacent node? Adjacent node is that we can call it the backup node for this node, for the affected node. So if something happened to this one, so this ONU will send to the adjacent node. Later, logically, we can see that if you do like that, then it means that you're going to congest the ONU 1.2 in this term. Yes, that's why we need some mechanism. How can we control the bandwidth in here? So here's the high level of architecture. Like I mentioned, we just working in the business and commercial customers, not in the residential customers. So here is the proposed SONU. I just want to compare between the standard and the proposed. So basically in the standard, SONU means the service ONU. What is the service ONU? Service ONU means that it can have higher functionalities inside the ONUs. And here, in the standard, each ONU can have more than one laser. One is for the working line and the other is for the protection line. So it can be up to 4. And in here, we are going to use 2. and we have the downstream receiver, and we have the protection line receiver, and we have the queue. So, like I already mentioned here, we need to consider about the, we call it the intra-scheduling. The queue is scheduling here, because if we try to satisfy only the EF, how about the other traffic? Should we drop the other traffic from the affected ONU, or we can try to find a good balance between the affected ONU and the adjacent ONU? Because now the adjacent ONU has been congested by the affected ONU. So here's just the architecture. We are going to discuss it in the more details. So if something happened to the primary line, basically the ONU will switch the working line to the protection line. How can it switch? We are going to discuss it later, because we have the detection mechanism as well. So here's the operation and detection and restoration mechanism at the OLT. So I hope it's not confusing. Remember, we have the report message. Report message is the message that is sent from the ONU to the OLT. So it's easy for the OLT to detect whether there is a fault in the system, because once the OLT did not receive any report message from that particular ONU, it means something happened to the system. So in the standard, they already developed the rules. How can the OLT detect if something happened to the ONU? And even they have the message, different kind of messages about the fault. It can be transceiver fault and the link fault. They have a different message. So here is just some example we took from the standard. So here is the loss of signal, LOS. So protection switching execution, alarm message generated by ONU and ONU actions. So here, if something happened to the ONU, for example, from the ONU point of view, if it doesn't receive any gate message from the OLT after 2 millisecond cycle time, then it will generate on if switch event of that ONU. After it generates, then it will switch the working line to the protection line, and then send the PON if switch event to the adjacent node. And after that, the ONU will generate the holdover start state. What is the holdover? It will hold all of the data until it receives the gate message, which contains the holdover end from the OLT. Later we are going to discuss about this. So here is just based on the standard, and what's the message will be generated, and what's the ONU actions, and what's the OLT actions. So here is the important thing, because the OLT needs to maintain the RG information table. Because OLT need to know, for example, this ONU, affected ONU, have how to say that? This particular ONU connected to which number of adjacent node, because each ONU will have only one adjacent node in this proposed architecture. So here is the idea: how can the OLT detect if something happened to the system? And now we are going to the ONU side. How about in the ONU? So in the ONU, once there is no any grant message, grant or gate message is the same, the affected ONU will wait for some time, T, where T is defined as the average waiting time for 2 consecutive cycles. Because we need to consider the 50 milliseconds. Remember the restoration time? So we are just waiting maximum 4 milliseconds. If after 4 milliseconds the ONU still did not receive any gate message from the OLT, it means that it will generate the message that I mentioned before, the on if switch event. So after that, it will switch and send the data with the protections line. And if not, it's just like a normal one. Later, probably when we see the example, we can have a clearer picture about that. Here's the other important thing. Let me go back first. So here. Just assume this one is the adjacent node. If something happened to the affected node, then the affected node will send the data with the protections line, which will be received by the SONU or adjacent node with this receiver, and then it will queue here. It means that now the adjacent node of this ONU have more data than before. So queue scheduling here is very important. Which data should be dropped, which data should not be dropped. So therefore, we need the quality of service intra-scheduling mechanism. At first, we need first to guarantee that the EF traffic can be sent first, because EF traffic, remember, 1/3 of the fiber disruption can be involved 911 call. Therefore, we need to guarantee the EF traffic based on the SLA. So here it can be based on the SLA. It depends on the network operators, whether they have the SLA or not. But for the business or commercial customer, I think they should have the SLA. So, I don't have time to talk about details about the MPCP message. So in the report message, basically, it can support up to 8 queues. So in here, we are going to use just 6 of it. 6 of it, yes. 3 is from the normal node, I mean the adjacent node, and the other 3 is from the affected node. It means that queue number 0 to queue number 2 is for the voice, for the data and video of the adjacent node. And the other, number 3 to number 5, is for the voice, data, and video of the affected node. So here, first we need to guarantee the EF traffic, and after that, then we can check whether we still have available buffer or not. I know that at the previous slide I mentioned that we need to guarantee the EF, but also maintain the other quality of service of the other packets. So why now you say you drop? Yes, it's because in our scenario, first, our SLA is based on the EF, and after that, we assume that the adjacent node always have higher SLA compared with the affected node. So therefore, in here, because the adjacent node have a higher SLA, it means we have no choice to drop the other AF and BE packet from the affected ONU. Only if the buffer is congested. But if not, if the buffer is not congested, then it means that we can have no packet drop. So I hope I can explain it clear. If you have any questions, you can just raise your hands and then ask the questions. So now is the DBA. So the previous slide, we are talking about the queue management, the queue scheduling. Now it's from the OLT point of view. So here is I think it should be the protections LLID. I think the appropriate name is not the multicast, but it's the protections LLID. So in the OLT side, remember we have the RG information table. so that the OLT knows which adjacent node that will be affected by the failures in the system. So based on that, then the adjacent node will be given the bandwidth more than the conventional one. For example, before the fault, that particular ONU will be given the bandwidth maximum for B min. But after the fault occurs, then that adjacent node will be given M times B min. What is the M? M is the number of faults in the system. For example, so if number of ONU in the system that affected by the faults. For example, if one fault, it means that 2 ONU will be affected. The affected ONU and the adjacent ONU. So this one, it should be 2. So double. We double the bandwidth allocation to that particular ONU. Why? Because that adjacent node need to send the data not only from its buffer occupancy, but also from the other affected ONUs. Therefore, we double the time slots. If 3, how about if 3? Then it's 3. So here's the example of operation upon the failures. So first, for example, something happened to that DDF1. And what's the next? Remember that this particular ONU detect. How can it detect? Based on the gate message. After 4 milliseconds, then, 4 milliseconds. After 4 milliseconds, then that affected ONU will generate the PON if messages. I will discuss later with the flow chart. I think it's better. So if something happened to this DDF, then this ONU will send the data to the adjacent node or the backup node. How can it send? It sends, first it will switch, of course, the transmission from the working line to the protection line. After that, all of the ONU data will be will be received by the ONU 1.2 here and separate the queue. Remember, we have 6 queues from 0 to 5. And after that, we do the scheduling, the intra queuing scheduling. After that, it will send to the OLT, and at the same time, the OLT, the OLT switch or activate the fault dynamic bandwidth allocation, like I already mentioned before about the fault dynamic bandwidth allocation. We give more bandwidth to the adjacent node of the affected ONU. I don't know, maybe it's too small, I'm sorry, because the picture also is quite wide, so I cannot put bigger picture about this one. So here's the affected ONU, and this is the adjacent ONU. So how can the affected ONU send the data to the OLT? Here is the concept with the message. From it starts from the PON if switch event until it receives the downstream data from the OLT, which contain the hold over N message. So first, if something happened to the working fiber, for example here, after 2 consecutive cycles, then the affected ONU did not receive any gate message, then it will switch the transmission time, transmission line from the working to the protections line, and it will send the message on its switch event.
And afterward, after it generates the PON if switch event, it will generate the hold over start. It means at this time, the affected ONU will, the state of this affected ONU is equal to the holdover. So I cannot send anything until I receive the message from the OLT that tell this particular ONU, okay, now you can send the data. Then received by the adjacent ONU will place this data as the important data and be categorized as the control priority packet. It should be number 1, and then send to the OLT, and the OLT receive the PON if switch event ONU, and after that it will send the gate message containing the holdover and the new gate message here. Because we are using remember the multicast LLID, is a protection LLID actually. So this ONU can receive and accept this packet and then send it, of course, to that ONU, particular ONU, this affected ONU. After that, then it can send the upstream data and so on. So we have the upstream and we have the downstreams. So I almost finished. So here is the state diagram. This is for the OLT and this is for the ONU. I think I don't have enough time to discuss about the functionalities of this one, but if you have time, you can open the IEEE standard for the SIPON 1904.1, and you can search for the activate data path function. What is this? What is this? What is this? And what is this? Every functions used in our proposed architecture have been stayed in the standard. So we didn't use a new message or something like that. It's just based on the standard because we need to care about this one. If we propose a new message, it means that we change the standard. So here's the state diagram. So first is if the primary loss is true or not. If something happened to the link or not. If something happened, then what to do? The OLT will stop the downstream data to that particular ONU and wait for the PON if switch event from that affected ONU. At the other hand, that particular ONU, affected ONU, will send the data from the primary to, disable the primary line